All right. What do we notice about this one? It's a cube. Ew. We have two cubes here technically. This is the same thing as x cubed. And what cube gives me 125? 5. Okay. So that helps because if we have a sum or difference of cubes, we have a pattern for it. Soap. Where we're going to have our, if we have two things that are cubed, we're going to have our first term with the same sign. Then we have our first term squared. We get the opposite sign. The product of both of them, always positive, b squared. So that's our little pattern. We do need to know that. So if that's something we don't remember, work on it. Because we need to know that. Because I can put this into factored form. I can get this piece factored with very little work just following that pattern. Because my a here is going to be an x. So our first piece is going to be our x with our plus, bless you, and a 5. Then we're going to have our x squared with a minus x times 5, a times b, also known as 5x. Always a plus 5 squared, 25. So we've factored our cube. We got it done in factored form. We're trying to get all the way to our solutions, to our x equals. I have 1 I can get to an x equals right now. What is my solution going to be here? Negative 5. We take our x plus 5, set that equal to 0, and we get our x equals minus 5. Again, you don't have to write that part out. If it helps you, write it. If it doesn't help you, don't write it. But what do we do with this guy? Let's see if we can factor it. See, do we have a pair of numbers that's going to multiply to make 25 and add to make negative 5? So if I can't factor it, what can we do? Quadratic formula. We're going to find our x equals using our opposite of b, with our b being this negative 5, plus or minus the square root of our b, negative 5 squared, minus 4, times our a, which is 1, times our c, which is 25, over 2 times our a, which is 1. Whew. Fill in all the pieces, and then we're going to work to simplify it. So, our opposite of negative 5 is going to give us a positive 5, plus or minus. Our negative 5 squared will give us 25. And 4 times 1 times 25 minus 100 over 2. So this is the same thing as having our x equals 5 plus or minus the square root of negative 75 over 2. I'm going to change the screen for a second. Bring it in. So let's simplify this just a smidge more because I don't like having that negative 75 there. Ew. 5 plus or minus. How can I split up that negative 75 into something that's actually not as gross? Yeah. Well, I'm going to split it. So we can do our square root of our, I'm going to split it up a little farther than that because our 25 is this, brain is not braining. Negative 1 times 25 times 3 gives me 75. It all means the same thing. And I can split these apart into separate pieces. Square root of negative 1, square root of 25, square root of 3. What is the square root of negative 1? I. What's the square root of 25? 5. And what's the square root of 3? Root 3. That one's super gross, icky. So I can write it as I times 5 times square root of 3. Generally, trying not to zoom it in. We tend to put our number, then the imaginary, and then the root. 5I root 3. If you put I5 root 3, that's fine. Just don't put the I inside the radical. And then we're good. And our denominator is 2. And it's gross, but we have 2 solutions here. Because we have our plus or minus. That means we have 2 solutions here. It's just that they're both complex and gross. When we have a cubic function, we should wind up with 1, 2, 3 answers. So we got 1, 2, and 3. We got 3 solutions here. Okay? Questions on this one? Okay. Because we're going to do another one that's very much like question number 54 from this homework, because I know that one was gross. So I want us to look at this one. I can't remember if this is question 54 or if it's like 54. Let me look. I don't know what section we're in. So 2, 4. It's not exactly the same as 54, but it's very, very similar. And we're going to see more pieces like this when we get into section 2.7. So we'll have more things that look like this and that we're going to approach in a very similar way. But we're going to kind of see what we can figure out here. It is not particularly pleasant. We've got a 4th. Ew. But what we're going to do is we're going to say, I really don't want to have to deal with a 4th and a square at the same time. Super gross. So we're going to make our own little substitution here. A lot of times we'll do some with a u, and it'll be called a u substitution. You may have heard that before, you may not have, and that's okay. I think Miss Hannah does it. Oops. So what we're going to do is we're going to look at this and we're going to say, ew, that's super gross. But I notice I have a 4th and a squared. So I have a 4 and a 2. They're very, very related. So I'm going to pick the littler one. And I'm going to say, okay, what if I let something else, I'm going to use a u, equals this middle piece here, x squared. I want to switch those things out because I'd really rather have 25 and just a single variable. I just want to have a u. I know that x squared is going to be what u is. It's just another variable. It's just one we tend to use for this kind of substitution. It gets used a lot in calculus. A lot. You do use substitutions a lot. We will do use substitutions a fair bit. It's not any mandate that you have to use u. It's kind of like why we always use x. Tradition. Yes, dear. Yes, you would just wind up with square, like x squared as your first term. You can absolutely do this without doing this u substitution, but I know a lot of people see this and get a little stuck. And so, yes, you can absolutely plow through this and just do it as normal factoring with x squared as your middle term. Totally works. But a lot of times we struggle with that one. So if I want to switch this x to the 4th out, it would be u squared. Because x squared is x to the 4th. If I take this and do u squared, I get x squared squared, it is x to the 4th. So this, if we ignore the stop line, is way easier to factor. If you can factor from here, absolutely awesome. More power to you. Go for it. Totally fine. It works. This just tends to be a little bit, eventually, easier to wrap our brains around sometimes. So let's factor this guy as it sits right here with the u's. So we have our pair of numbers. We want to see a pair of numbers that multiplies to make 4 times 36. That's 144. And adds to be 25. What pair of numbers is going to multiply to make 144 and add to make 25? 16 and 9. That tells us how that middle term splits apart. So I'm going to do this with my factoring by grouping. If you want to do this with a box, totally works. However you factor, I don't care how you factor, just that you factor. So we're going to have our 4u squared. What this tells us is it tells us how this guy splits apart. So we're going to have our plus 16u and our plus 9u and our plus 36 equals 0. So at this point, it's just factoring using a u instead of an x. So I'm going to split this up into my pairs so I can do my grouping. However you want to factor is totally fine. I'm going to pull out my 4u, u minus 4, and we have a 9 plus, thank you. I was just noticing I'm going, oh, something looks wrong here. Sure. So getting it into factored form, I have these two pieces that are the same. So we're going to have our u plus 4 and our 4u plus 9. So I could figure out my solutions here. What does u equal for this factor? Negative 4. Ooh, that looks green. There we go. What does u equal for this factor?
9/4.
Watch your signs. Negative 9/4. Minus 9 over 4. Because we 4u plus 9 equals 0. Minus 9 to both sides. Then divide by 4. So if I was just wanting my u solutions, we'd be great. But I was starting with x's, so I need to end with x's. But I know that u is x squared. So I can take the fact that I know that u equals minus 4 and switch that back out. I want x squared equals minus 4. What's x going to be? How do I get x by itself? Square root both sides. How do I simplify square root of negative 4? Plus or minus 2i. I have 2 roots right there. We're going to do the same thing with our negative 9/4. Our u equals negative 9/4. And again, I know that u is going to be my x squared plus negative 9/4. When we take our square root of both sides, what are we going to get?
Plus or minus 3 over 2i.
And you can either put it as 3i over 2, or you can put 3 over 2i, 3 halves I, 1.5i, however you do it. I'm seeing many confused faces, so I'm going to split this down for a second. Because I can put my x, whoa. Try again. X equals our square root of negative 9 over our square root of 4. Plus or minus. Okay? So, as we go more and more through the year, we're going to see a lot more of these kinds of problems. They're called quadratic type problems because if I swap something out, we make a new quadratic. If you plow through this and you factor this with x squared here, and you get x squared plus 4 times 4, x squared plus 9, that's totally fine. You'll get down to the same answers. It's just for some people that is a lot harder to spot and work with dealing with an x squared. If we swap it out for something else, sometimes it's easier. Okay. Questions on this one. So 54 is a weird one and uncomfortable. What questions on that one? Okay. Because we're going to go do a little bit more solving stuff. And it's going to be one of those times where it feels like we make a big jump. because we're going to start section 2.5 right now. And this is solving other kinds of equations. So we're going to start with absolute values. We're going to look at some exponential stuff. We're going to look at some roots, all kinds of other pieces, things we've seen before. Yes, dear. So if we know that the absolute value of x plus 7 is 9, that happens. What do we know is going to happen here? What are we going to do? Yeah, we have two options here. With our absolute values, what that's telling me is my distance from 0 is 9. It is 9 steps away from 0. So it could be that our x plus 7 is just sitting at 9. This is 9 steps from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 steps from 0. It could also be 9 steps that way. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's still 9 steps. So we need our x plus 7 is a positive 9, or my absolute value could equal a negative 9. So our x plus 7 could equal negative 9. We have two options here. And then we need to solve each of them. So what is our solution going to be on this one for the top for our positive 9? X equals positive 2. What about for our negative 9? What's going to happen down here? Negative 16. So we have two solutions here, and they're both important. So we're going to isolate our absolute value, and then we split it. So we got to get our absolute value by itself first before we just start splitting things. So on this next one, we need to do some things first before we split it into two pieces. What do we need to do before I can do my two separate absolute values? Add 8. Absolutely correct. Add 8 to both sides. It's going to give us 3 times our absolute value of x minus 4 equals 10. Then what should we do? Divide by 3. That's going to make this 3 and that 3 cancel out. We're going to have our absolute value of x minus 4 equals 10 thirds. Ew, but we can do it. Now that my absolute value is by itself, I can look at my two possible options. Because my x minus 4 is 10 thirds of a step away from 0. We're starting to decimals, it makes way less sense, but that's okay. So our x minus 4 could absolutely just be 10 thirds. Those absolute value bars might not be doing anything. They might just be there for decoration. Or those absolute value bars might be working their tails off, and my x minus 4 might actually equal our negative 10 thirds. It has two options, either positive or it's negative. We need to solve these now, finish them up. What are we going to do to get our x by itself here? Add 4 to both sides. So if we have 10 thirds plus 4, what are we going to get? Say it louder. 22 thirds. Yep. 22 over 3. Because if we add 4 to both sides, that's the same thing as adding 12 thirds. 12 thirds plus 10 thirds. 22 thirds. What about for our green one over here? 2 thirds. Because again, we're adding that 12 thirds. Negative 10 thirds plus 12 thirds. We have a positive 2 thirds. Okay. Questions on that one? Because that one had a lot of steps. And it has been a hot minute since we dealt with absolute values. In any way that wasn't the crazy way from chapter 1. Okay, let's try the same thing on the next one. What's my first step going to be over here? add 4. So I've got my -2 absolute value, x plus 8 equals, adding 4, we have 10. Then what? Divide by -2. So we're going to have our x plus 8 equals -5. Then what? To what?
X plus -5 and x plus 8 equals -5, and then x plus 8 equals positive.
I was going to say, that is 100% a super common thing we say. Absolute values, are they going to equal a negative number? Because it's how many steps. That's our distance. We don't measure distance in negatives. Absolute values don't equal negative numbers. So watch out for these. If we get a negative number, absolute value equals something negative. We cannot make that decision up here or up here. If our absolute value equals something negative, I can't split it because I'd be trying to make it, negative and double negative. So absolute values cannot be negative. This doesn't have a solution. So this is going to be a no solution. And I'll just write it up here because you don't have to write this part. I just like to have it written down in case someone's looking at the notes later going, why? There we go. Absolute values can't equal negatives. They can equal negative values. So be super duper careful with that. That is the most common mistake made on absolute values is that we get the negative number and we're like, boom, keep going. So just be careful, okay? Absolute values we've worked with before, they're not brutally awful. We can do absolute values, just watch out for these negatives. They're kind of tricksy. So the next kinds of problems we're going to see when we're looking at solving other kinds of equations, which is what they call this section. Oh, yeah, you can do it. So sometimes we'll have stuff that's ickier. We've got cubes and weird and blech.
Would make me feel better if I collapse it.
Oh, you could put it in the paper recycling if you'd like, because it counts. Okay. All right. We've worked with stuff like this. Oh, that's fun. This one actually doesn't have a slit in the plastic. There we go. This one didn't have a slit in the plastic to pull the tissues out. It didn't have a good slit in the plastic to pull tissues out.
Oh.
So I was trying to take the first one because it always makes sense. All right. On the first one, we're already set equal to 0, which is a good first step for us because we need to set them equal to 0 to try and factor. And we actually got a clue in our instructions. When we have obnoxious numbers of terms like this, go for groups. We have here a polynomial with 4 terms. Ugh. So I would break these into smaller pieces so I don't have to deal with all of them at the same time. Ew. So I'm going to break this guy apart here. I'm going to break these guys apart here, but I am squeezing a plus in. I always want to have a plus in between my groups. You don't have to. You can leave the minus sign there, but then you have to be super careful about which sign you take out. And again, you can factor this however you want. You can put this through a box. Just make sure that this is in the spot where like our x squared would normally go, and this would be in the spot where our constant would normally go. So you can do it in a box if you are a box stamp. Go for it. And then we're just going to factor GCFs of each pairs. What is shared between 9x cubed and 18x squared? 9x squared. And left over, we're going to have an x minus 2. What is shared between minus 4x and 8? Negative 4. And left over, we're going to have our x. What sign's going to be over here? Minus 2. That is why I always try, it's not a laser pointer, I always try and have a plus in between here because it's a lot easier to see this as a -4, taking that out, if we can see the negative. If we just put our parentheses covering this up, it's really easy to lose track of that sign. Because these two pieces need to equal each other, the two green pieces need to match in order for us to finish this solving. Because what we're doing is we're taking this chunk out as its own little GCF. I tend to put that one in front. So we've got our x minus 2. And then all those leftover pieces are going to go together. We're going to have our 9x squared and that minus 4 equals 0. Now what should we do? It's a difference of squares. Yes, it absolutely is. This guy right here is a difference of squares, which I tend to just write DOS because lazy. So if I want to put that into factored form, what squared gives us 9x squared? 3x. So that's what's in the front. What squared gives me 4? 2. One set of factors gets a plus, one set of factors gets a minus. And then this x minus 2 is still just showing up here. And it's all still equal to 0. So now what we have is we have this whole thing in factored form. No quadratic formula needed, nothing super duper hog wild. Good to go. Mm-hmm.
Like, well, when we're solving for x, we just write x equals plus or minus 2.
I'm good with that. Yep. I'm going to put them as three separate roots, but if you notice the plus and minus parts, I'm totally okay with that. I just tend to write them all separate because it makes it really clear if you're looking at it and are slightly lost. Because what is our solution for here? What is our root going to be for this x minus 2?
2.
X equals positive 2. What about for our next factor here? What's our solution going to be? Negative 2/3. And if you write that out, 3x plus 2 equals 0, minus your 2, then divide by 3. That's totally okay. You do not have to do this in your head. Write it down if you want to, if you need to. What's our other root going to be? Positive 2/3. Those are our three solutions. When we have a cube, we should wind up with three solutions. Very, very rarely will we have less than that. Only if we have one that's exactly on a root where we have like x minus 2 squared or x0 squared, where we'd have like a bounce root. That's the only time it's going to look like less than 3. Because we can get to imaginary roots. We can get them. Questions on that first one of these? Because these polynomial ones are unpleasant. They're awkward. But we can do this. What do I need to do first on this next one? Make it equal to 0. Do not just start factoring where they are. Make it equal to 0 first. So we're going to have our 4x to the 4th plus our 10x cubed minus 6x squared minus 15x equals 0. What do we do next? Like, you can group them here, but there's actually something that would make things easier if we do it first. We have a GCF. What's our GCF? X. By taking an x out, that's going to leave us with our 4x cubed plus 10x squared minus 6x minus 15. So watch out for GCFs. They'll happen in polynomials too. Now what are we ready to do? Factor it. Put it through our groups. Put it through your box. Whatever tools we use that. I'm going to do grouping.
Do I just keep the x's line?
Oh, yeah. The blue X out in front, he's my obnoxious little line leader. He's going to stay at the front so we get all the way down to factored form. He's just waiting at the door about 5 minutes too early. He sits there and we ignore him. So we're going to pull out our things that they share, things that are shared between 4x cubed and 10x squared. We're going to have a 2x squared. And leftover is going to give us a 2x plus 5. And then shared between our minus 6x and minus 15, we're going to have a minus 3. And that's going to give us a 2x plus 5. So writing this in our fully factored form, we're going to have our x and our, I don't want that one on green, 2x plus 5 and our 2x squared minus 3. Questions as it sits right now before we go in for roots? Yes, dear.
Factor out your x with that, like your parentheses will be the same.
Say it again.
You take away the 15, x of the parentheses will be the same when you factor it.
If you take away the 15x,
You factored out the x and the 50. I'm asking that so we can get 2x plus 5 on both sides.
so this x,
Yes.
so I factored this out of everything because it was the greatest common factor. So the 15 is still here. It's just, if I distributed this back out, I would get exactly what we had up here with our 15x. So the 15 is still hanging out. We just took out a GCF of x. And the 15 is still here. I put this 3 and the 5. So I didn't move the first.
Unplug it.
Okay, so the 15 is still here. We just pulled the x over so that everything is out. You can do it. You're just going to wind up with weird factors in here with that GCF of x in there. It makes things super awkward. I have no idea if I actually answered a question or not. Okay. Sometimes I just explain and kind of hope it fills in whatever gap was there. Okay, so now let's see if we can find our solutions, our roots. Because we've got this down into a factored form. This is not a difference of squares. You can try to, you could do that, but it's going to be unpleasant. There's an easier way. Let's do that way. What is our root over here? X equals 0. Boom. Because we're set things equal to 0 to find our solution. How about for the green one? What's our 2x plus 5 going to give us as a root? Negative 5 over 2. I'm going to write this next one out. Because we can try and do it in our head, but it's a little awkward. We're going to take our 2x squared minus 3, and we want to know when that equals 0. Add 3 to both sides. So we're going to have our 2x squared equals 3. Divide by 2. We get our x squared equals 3 halves. And square root both sides. We're going to have our x equals, whenever we square root, we're going to put our plus or minus square root of 3 halves, square root of 1.5, however you want to do that. When we're looking at these roots, I'm not going to make you rationalize them. Technically we should, but you can also type it in the calculator like that and it'll rationalize it for you. But we have our 1, 2, 3, 4 roots because we had a 4th degree function. Okay? That is a really easy way to kind of spot check and make sure we got all the things we needed. We're going to do just a teeny bit more. It's things we've done. Fraction exponents. We've worked with these. We can do this. These will be the last 3 today. We'll stop here. We can do these. So we have x to the 3/4 equals 125. Ew. What does the x to the 3/4 mean again? No. We've got our power. What's the denominator? The index. That's our, the square root has an index of 2, cube root has an index of 3, fourth root has an index of 4. It's a little number that goes in the crook. So I could write this as my fourth root of x cubed. Oop. Or we can do it in the other order. I could do my fourth root of x cubed. Either way, I can write it either way. It means the same thing. So if we look at 125, what do we know about 125? It's a cube. If we've got a cube, I'm going to put the cube on the outside. So I'm going to set it up with this guy. I don't know why I switched. Because if I have something cubed, what do I do to uncube it? Cube root. If I cube root both sides, definitely smashed my stylus into the file cabinet over there.
What?
I definitely smashed my stylus into the file cabinet and almost snapped off the tip. Because if I want to cube root both sides, we're going to have our fourth root of x, or x to the 1/4 if you want to keep it as a fraction, that's totally fine, equals cube root of 125 is 5. How do I un-fourth root something? Raise it to the 4th power. Because that's going to make the 4th root and the 4 cancel out. So we're going to be left with just our x over here. What is 5 to the 4th? 625. So we can work them in pieces. That's totally fine. When we have more than one term like this, we're going to need to do a little bit of factoring. It's going to feel weird, but we can do it. So on this middle one, I'm going to start us out with it. I'm going to set us equal to 0. So we're going to subtract 5y from both sides. So we're going to have our y to the 3/2 minus 5y to the first equals 0. If it helps to put the 1 there, put the 1 there. If it does not help, don't put it there. And then what I'm going to do is I'm going to say, okay, I see y's in both of these spots, and I don't like having 2 y's. Ugh. So we're going to factor out a y to the first. If I take 1y out of y to the 3/2, what am I left with as the exponent here? 1/2. And if I factor a y out of 5y, we just get our minus 5. So I'm factoring out a y. It leaves me with something gross, but surprisingly we can deal with this. Because this one we can deal with and get our root from it, y equals 0. That's our solution. The right side, we're going to have our y to the 1/2 minus 5 equals 0. And what can I do there? Add 5. Y to the 1/2 equals 5. Remember, y to the 1/2, that's the same thing as the square root of y. How do I get rid of that 1/2-ness? Square both sides. 1/2 times 2 is going to give me that exponent of 1. You can think of it that way, or you can remember that y to the 1/2 is square root of y squared. There we go. 25. And we have 2 solutions here. Okay. So the one on the right is very, very similar. We're going to get things together. We're going to factor. This is the last one, I promise. So I'm going to set it equal to 0 first, and I'm going to make a different color choice so we're not just using that same purple. x to our 3/2 minus x to the 1/2 equals 0. Setting it equal to 0. I could factor a whole x out, but then I'm going to have fractions in more than one place. Ew. So what if I factor out x to the 1/2? What are we going to be left with? X minus. I heard it, but it was very tentative. Say it again with confidence. 1. We can factor stuff out even that looks gross. We're going to have our x to the 1/2 equals 0 as one of our solutions. So what is that solution? X equals what?
X equals 0.
0. Because we'd square both sides. 0 squared, still 0. And then what's the solution on this one? X equals 1. Okay, so when it's dealing with these fraction exponents, we can do that. Like, it's not pleasant, but we can do it. This one? Square both sides to get rid of the power of 1/2.
Oh, okay.
No, good question, good question. Okay. So we are going to keep working with more kinds of equations. Like tomorrow, we're going to work with a lot of radical things. And we'll start getting into some of those quadratic type where we have to do substitution. I'm going to put this up here. I've got homework 2-4, which is technically due tomorrow, and 2-5, which is what most of today was, is not due until Friday.
Do you like my sweatshirt?
It's beautiful. I almost got that when I was at the zoo last time. Except I really struggled to pay more than $20 for a shirt.